In this lesson, we will create a finish toolpath. We'll discuss tool compensation, plunge parameters, and we'll use geometry to avoid a plunge cut. I have the part from this lesson open, left spindle, finish turn, and cutter compensation, and saved it as my in-process file. This is the same part we left off with in the last lesson. So I'm in the turning tab. I'll go to the finish toolpath. Now if you have your part open from the last lesson, you can just use the last selection. If you don't, I'm going to chain it at this chamfer here all the way to the back side here. Now the direction of these arrows is important, obviously. I want it pointing towards where I want my cut to go. I'm going to select T0202. I'm going to put a comment in called left spindle finish turn. I'll adjust my spindle speed a little bit, my constant surface footage, and my max spindle speed. Let's take a look at finish parameters. Now if I want to have more than one pass, I can, and I can tell it how deep I want that step over to be. This is a finish operation, so I'm going to leave nothing in X. I'm going to leave nothing in Z. For tool compensation type, so far we've used compensation in computer. In this case, MasterCAM compensates for the radius of the tool. If the radius of the tool is changed, the tool needs to be updated in MasterCAM and the code reposted. Another option is compensation in control. In this case, MasterCAM outputs NC coordinate values exactly from the chain geometry. The coordinates would match the dimensions of the print. And it outputs a G code that the machine recognizes as cutter compensation. The radius of the tool in its quadrant must be correctly recorded in the machine control, and the machine compensates for the radius. The benefit of this type of cutter comp is if the radius on the tool in the machine is changed for whatever reason, it is not required to update it in MasterCAM. The radius recorded in the machine control can be changed, and the machine control will adjust the amount being compensated. It is good practice to update the MasterCAM file for record-keeping purposes if the tool nose radius in your job has changed. There are some other selections we can use here. They're not used quite as often as these first two. If you'd like to learn more about them, please go to Help and read more about them. I also have compensation direction. This setting determines which side of the chain geometry to compensate the radius of the tool. So for visualization purposes, if you pretend to stand behind the radius with the arrow pointing away from you, the geometry should be on the same side as the arrow. We can also roll our cutter around the corners or not, or we can keep them sharp. So let's update our lead in, lead out. Our lead in is fine as it is. For our lead out, I'm going to add a line like we did last time. I'm just going to make it a little shorter so that I don't cut material that was left behind by the roughing toolpath. So we'll call this 50 thousandths. And let's take a look at our toolpath. So I can select back plot here, or I can select back plot up here. If I do it down here, I get the individual toolpath. I'm going to hit the S key and step through it. So you'll notice that our toolpath goes above these undercuts here. Let's take a look at why that is. I go back into my parameters. I have a plunge parameter option, and you can see that I have a little diagram that shows I'm not going to do any undercuts on the diameter, and I'm not going to do any cuts on the face. In this case, I need an undercut on the diameter. I would also get it on the face with this selection, and I can choose either or with these other two options. I also have back clearance angle here. It's got a default value of 3, so this value will be added to it, whatever the current angle of the tool is. I can also change the angle on the front clearance of the tool as well. So let's go ahead and try this with our new setting. We'll regenerate and then backplot. Again, I'm just going to step through it so I can see it. And because it's 35 degrees, I'm able to come down this angle right here and get it in one shot. But it also wants to come down into this area here. And you can see I was not able to get all the material out of here, and it also came down in here quite a bit. This cut here is good. I'm happy with that cut. This cut here, I'd like to let my grooving tool do this cut. I would also like to have it not do this back chamfer. I'll do that in the right spindle or when I flip the part around. So in order to do that, I'm going to need to add some geometry here and here, because once I've opened up the plunge parameters, it's going to plunge wherever I allow it to. So let's go ahead and do that. I want to go to my levels, and I do have my toolpath geometry selected here. I can right click and change my thickness and my color if I choose to. Let's go ahead and make this, we'll make it this bright blue. So I'll go to wireframe, line endpoints. I'm going to create a line from here all the way. Now if I make this horizontal, I can snap it to right here. And then from there, I'll just modify the length. I'll lengthen it by a distance of 50 thousandths. And that'll get us back to the same place we were. So now I'll go back to my toolpath. And if I want to look at my current geometry, I can click on the geometry. You can see what I currently have. And I want to rechain this. So I'll right click and rechain all. I'll grab the chamfer in the front again, and I'll come all the way to this last entity here. And you can see that it grabs it very nicely. I'll green check out again. I'll regenerate here using regenerate all dirty operations. And if I grab my toolpath, I'll just drag my slider bar. And I've undercut down inside of here, and I've left material here for my grooving tool, and I'll do this on the back side.